In this demonstration, I'm using Packet Tracer to observe the behavior of Ethernet on a local area network. Now, I've got Packet Tracer and I have 5 PCs here, and each PC has an IP address: 192.168.0.10, 11, 12, 13, and this one here is 14. So 192.168.0.14. And if we open up the PC, you'll see that it does have the address. If I go to IP configuration, it's got the IP address and the subnet mask. Okay, so we have these 5 PCs and PCA to PCE, and they're all connected to a hub. Now, Ethernet was originally designed in carrier sense multiple access with collision detection to work on a shared network. And some of the early implementations with ThinNet were a coaxial cable where everybody connected to the same cable. Well, then with straight through cables, unshielded twisted pair copper cables, hubs were created, and then every device could connect to the hub as the centralized location, but still it was a shared network. In other words, if I send an Ethernet frame on this network, it's going to go everywhere. It's going to reach every device, and the hub will forward Ethernet frames out of every port except the one it came in on. Let's take a look at this. And this is the way Ethernet was designed. It was designed for a contention-based medium where you have multiple devices. They all have MAC addresses, and the devices that are intended to be the receiver, they take the frame, and the devices that are not the destination MAC address will drop the frame. So let's see here. We'll see this in action. So what we'll do is we'll go to simulation mode, and you can see I've already set it from show all protocols to show none. And we're going to edit the filters here. We'll just say we're interested in just ICMP, a ping. Okay, and once again, I'm in simulation mode. And now I'll open up PCA, and I'm going to ping 192.168.0.14, which is PCE. So I'll hit enter, and that loads up this ping right here, this ICMP ping from PCA. Now we can watch as it travels, as this frame travels and hits the hub, and what happens when it hits this hub. And once again, this is the way Ethernet was designed to function. So we'll hit forward. There it goes. It hits the hub, and now the hub is going to forward this frame out of all ports except the one it came in on, and then the frame reaches all devices. Okay, however, you can see here the blinking red X's. These are not the intended MAC addresses. PCE is. So if we see here that if we look at the inbound PDU details, the destination address was the destination MAC address and ends with 295C. 295C. And if we look at this PC and we open up a command prompt and do an IP config /all, we can see that the MAC address is 295C, just like, 295C, the physical address, the MAC address, right here. So since the destination MAC address is 295C, this device is that MAC address, PCE, so he accepts it, and the other devices drop the frame. Now he's going to reply, and when he replies, the hub is similarly going to send it everywhere, and the devices that were not intended to receive it, it's not their MAC address, not their destination MAC address, they drop it, and PCA accepts it. Because, if we look in the packet, inbound PDU details, the destination address here is BA81, and PCA is BA81. We'll test that out here. So, and to test that out, I'll say IP config /all, and we'll stretch this out. And you can see physical address BA81 is the last 4 hex characters. So that's the one that accepts it. Now let's clear this, we'll reset the simulation, and this time we're going to do something differently. This time we're going to try to do the same type of thing, but we're going to cause a problem. On an Ethernet network, when we have a shared medium like this with a hub, A hub creates a half duplex situation where only one device can send or receive at a time. And Ethernet was designed that anybody can send or receive at any time. However, if two devices happen to send at the same time, we get a collision. And there's collision detection that happens. This is CCNA CD. And when a collision happens, basically all devices need to stop sending. There's a jamming signal sent out for all devices to stop sending. And then a back-off algorithm is run, and they wait for a random amount of time, and then one of the devices can start resending. In other words, the collision stops the communication from happening if two devices happen to send at the same time. So we can demonstrate that here in Packet Tracer by using this little button here. This will create a simple PDU. This will be a ping. If we just click on this button and say, I'm going to send from PCA to PCE, and then I'm going to click here again, but also send from PCC to PCB. So now I have two pings that are happening from here to here and from here to here. Now, these are going to happen at the same time, and basically what's going to happen is there'll be a spike of voltage on the wire, and the frames will be destroyed. There'll be a collision, and the pings should fail. So we'll try this. Notice here, there's two attempts here in progress. PCA to PCE and PCC to PCB. It's in progress, and we'll click go. There it goes, and we'll click go, and it's attempting to go out. Notice things are going and everything's on fire. So we have fire here. We have achieved fire, and we have failure. So basically it didn't work out, and you can see here failed and failed. And that's because you can't have two devices sending at the same time in a collision domain like this, where you have a hub and it's a shared medium. And basically that's not going to work out. And that's the way Ethernet was designed. It's designed to have MAC addresses so that we know which devices pick up the frames and which drop the frames. And it was also designed that so anyone can send at any time, but if two devices send at the same time, we have a collision and there's a problem. Now, in reality, what happens is the back-off algorithms run, and then one device can eventually send, and eventually send, and eventually there'll be success. But the network has to deal with all of these collisions, and there has to be a jamming signal, and basically you end up with a slowdown on the network.